Good morning, guys. Today we're going to start with Chapter 8, and we're going to be talking about right triangles and trigonometry in this chapter. So to begin with, let's talk about the Pythagorean Theorem. So here's our objectives for the day. You're going to be able to do what you did in middle school. You're going to be able to use the Pythagorean Theorem to find the missing side lengths of right triangles. The second thing is you're going to be able to use the Pythagorean Theorem to determine what type of triangle, acute, right, or obtuse, given the three side lengths. What state standard are we covering today? Well, it's the new state standard. It's T1, prove and apply the following, prove and apply theorems about triangles, including the following. Measures of the interior angles of a triangle sum to 180, we know that. The isosceles triangle theorem and its converse. The Pythagorean theorem. The segment joining the mid-segments, we've done that. So let's get started today. Pythagorean theorem, hopefully you remember this all from middle school. A squared plus B squared equals C squared, the three sides of a right triangle. So let's talk about what a right triangle is in the parts, remember. Remember a right triangle, you have the three sides. The two sides that meet at the 90-degree angle are the legs, and the third side, opposite the 90-degree angle, the hypotenuse. Couple facts you need to remember. The hypotenuse is always the longest side, since it's opposite the largest angle. Remember from the triangle inequality theorem that the sum of any two sides must be greater than the third side. So what that means for us is that the sum of the legs must be greater than the hypotenuse. If that's not the case, then we can't make a triangle from those three sides. So let's look at our first example, and let's find a leg. So the first thing we're going to do, we are looking for the leg. We're going to determine what our possible values are. We're going to have some number sense and make sure that what we get is reasonable. Remember that a leg can't be greater than the hypotenuse, so we know that this y has to be less than 12. But the sum of the legs must be greater than the hypotenuse, so y plus 8 must be greater than 12, so y must be greater than 4. So when we solve this problem, we have to know that our answer should be somewhere between 4 and 12. So now we'll find the length with the Pythagorean theorem. 8 squared plus y squared equals 12 squared. 8 squared is 64, y squared, or 12 squared is 144. Y squared equals 80. Therefore, y equals 8.94. We get the answer that we're looking for, somewhere between 4 and 12. The second type of problem we'll solve, we'll be looking for the hypotenuse this time. Legs are 6 and 11. So again, the first thing we're going to do is we're going to make sure what our possible values are going to be. Hypotenuse is the longest side, so we know that x has to be something more than 11. But the sum of the legs must be greater. Therefore, 6 plus 11 must be greater than x, so x must be less than 17. So our answer for the hypotenuse has to be somewhere between 11 and 17. Let's find the hypotenuse. So we'll do the Pythagorean theorem. 6 squared plus 11 squared equals x squared. 6 squared, 36. 11 squared, 121. That gives us a sum of 157. Remember, to unsquare something is the square root. 12.53. Greater than 11, less than 17. Pause the video. Do this one on your own. Now, the other thing that we can do with the Pythagorean theorem, not only can we find missing side lengths, we can also classify triangles by their angles based upon the Pythagorean theorem. Of course, a squared plus b squared equals c squared. Well, that means we have a right triangle. If a squared plus b squared is greater than c squared, we have an acute triangle. All the angles will be less than 90. And finally, if a squared plus b squared is less than c squared, it means we'll have an obtuse triangle. Don't forget, make sure that the side lengths can form a triangle first. That means the sum of the two shortest sides must be greater than the third side. Take a look at example 3. Determine whether each set of numbers can be the measures of the sides of a triangle. 7, 14, 16. Well, 7 plus 14 is 21, which is greater than 16, so yes, it can be a triangle. So we'll put 7 squared and 14 squared because those would have to be the legs because they're the shorter two. Compare it to 16 squared. 7 squared, 49. 14 squared, 196. 16 squared is 256. Adding those two together gives us 245, which is less than 256. We have an obtuse triangle. Look at B. 11, 60, 61. 11 squared plus 60 squared. Again, 11 and 60 have to be the legs because they're the shorter two sides compared to 61 squared. 11 squared is 121. 60 squared is 3,600. 61 squared is 3,721. 121 plus 3,600 is 3,721, which equals 3,721. Therefore, we have a right triangle. And since I kind of spoiled it because I gave it away too quickly, 6.2, 13.8, and 20. Well, remember, by the triangle inequality, the sum of any two sides must be greater than the third side. So if we add 6 plus 2 plus 13.8, we get exactly 20. Therefore, these three sides cannot be a triangle. No need to do the Pythagorean theorem because it can't be a triangle. And that is lesson 8.1.